Good morning. I wanted to do a brief talk on LLMs, large language models, and some of their inherent limitations, at least in this first generation. So right now, kind of a simplified overview. The way that these LLMs work is by predicting the next word, basically, in its response. And these are broken up into tokens, and so a lot of times you'll see LLMs spoken of in terms of how many tokens they can process at once. That's what that's referring to. It's referring to basically the next word in text. And the way that it learns to do this is by being trained on billions and billions of already existing pieces of writing. And over time, as it trains on those things, it gets really good at predicting what the next word should be. But what it's not doing is performing any type of abstract reasoning. Now, you could say that text prediction is a type of reasoning, but it's not the type of thing that we would speak of when we're talking about human reasoning. And so, for instance, something that LLMs are known to struggle with is the multiplication of large numbers. And if you think about how they work, that kind of makes sense, because even if you read a whole bunch of books, you're unlikely to be able to just look at two numbers, see a symbol between them, and then be able to predict the next word. Instead, you would have to actually calculate this multiplication problem in order to get the right answer. And so you can try this experiment. If you ask something like GPT to multiply two large numbers, you're probably going to get something close, like here. It gave me something close, but it was still incorrect. And this type of thing shows that even though GPT has been trained on thousands of math textbooks and tens of thousands of mathematical papers, it still doesn't actually understand multiplication. It doesn't understand numbers and the relationship of numbers between each other or calculation. Instead, it's just trying to predict the next word according to stuff it's read before. So right now, the way these work can be compared to this thought experiment called the Chinese room. And it goes like this. Suppose someone who doesn't speak Chinese is in a room full of Chinese symbol books. The books contain instructions on what to write in response to a sequence of Chinese. And then pieces of paper with Chinese are passed underneath the door to the person inside the room, and they use the symbol books to respond. So to the person who's passing the papers under the door and receiving the response, it seems like they're having a fluent conversation with someone who understands their language. Meanwhile, the person inside does not actually understand anything that's going on. And that seems to be kind of an inherent limitation within LLMs. The way that they're made is based on prediction. It's not based on actual understanding. So it's kind of like this Chinese room. So going forward, in some ways, an AI that could emulate even just a 7-year-old human being with very basic reasoning skills would in some ways be more impressive than currently the most advanced LLMs, because it wouldn't just work on prediction, it would work on actual reasoning. And so it wouldn't just try to predict the multiplication problem, it would actually do the multiplication like a human being would. That type of thing doesn't really exist right now. But if it did, it would have to have things like a working memory, being able to focus its attention, having its own goals, and using problem solving to work towards them on its own without a prompt. Being able to update its own beliefs as it learns, even if it lacks information and has to make likelihood judgments, and that kind of thing. So that type of thing could potentially use LLMs as a part of itself, somewhere in its reasoning, but it would have to look fundamentally different than first generation LLMs that are just using text prediction or maybe some very basic reasoning. The thinking would have to look fundamentally different in order to have a more general application. So that's basically all I had. I'm not an expert on AI, but this is just something I found interesting. And thanks for listening.